Good morning, everybody. And can you hear me, sir?
Yes, we can hear you. Please go ahead.
Okay. So this is a good morning to all of you. And detection of oil tank from high resolution remote sensing images using morphological and statistical tools. So basically, main contribution here that we know that oil tank for the defense application is a very important target, and how to detect the automatic. Actually, we are working for the missile guidance system. So that's why these targets are useful for our application.
Excuse me, Dr. Debasis.
Yeah.
I'm sorry to bother you. If you don't mind, can you increase the volume of your system, please? Or can you show your screen? We can see what is wrong in the audio so we can check it.
Now it is audible?
It's audible. We can hear you, but it's very weak.
Just 1 minute, sir. Give me time.
Yes, brother.
Hello. Hello.
Yeah, go ahead.
Can you hear me now?
Yep. We can hear you. Yep.
Better at least.
Yeah, better at least. Yeah, compared to previous one.
Okay. That is a net problem here. That's why it is maybe.
But go ahead. Why don't you start?
Yeah. So this proposed method actually it is in spatial and spectral properties domain knowledge regarding the character of targets. Multiple steps I have designed here to find out my oil tank. First of all, the target itself is very complicated, and there are high resolution data, so detection of a particular target from the rest of the image is difficult. So before going to cluster or segment, I impose an enhancement technique, which is used by the directional morphology. And in that particular enhancement technique, its beauty is that a particular target which I am look after, so I am extracted the structuring element, and using this particular enhancement technique, I am enhancing the particular object which I am looking for extracted, and the rest of the objects are depressed. So for me, it is very easy to get a segmented result. Now, multiple seed-based clustering procedure we are using by the internal gray variance, then binarization and thinning operation, then circular by Hough transformation detection purpose, then MST-based spatial relationship grouping operation, because the oil tank and the other tanks also there, but the oil tanks are most clustered form. So that's where MST-based clustering technique we are using here to form a group. Then supervised minimum distance classifier for oil tank detection for my classification purpose. This is the whole flowchart of that algorithm. The input image, then enhance whatever I have already discussed. This is the whole architecture of the algorithm. Now, the enhancement technique, see, this is a 5x5 block. In that 5x5 block, I have different direction, horizontal. This is my candidate pixel. This particular color is horizontal. This is vertical. This is right diagonal. This is left diagonal. And using this particular, this is a window-based operation. So in a particular candidate pixel, we are extracting the mean gray value by taking the difference for the erosion purpose taking the difference from the original image and the structural element. Whatever the structural element will be the file type. That structural element I have stored by cutting a 5x5 element. So then I am computing the standard deviation. Then for all direction 1 to 4, is all direction I am computing. Then find out the minimum. The minimum, that means it is that in that direction where the standard deviation minimum, that means it is more homogeneous in that direction. The perform gray level erosion in the using this structuring element in that direction. So I am doing here the structuring element, whatever I am taking, the erosion also I am doing the direction which I am getting by the dmin. Then the contrast stretching between 0 to 255 because our data is 8-bit data. Similarly, then for the dilation, so it is a morphological operation, alternate operation, erosion and dilation. Then we are doing this purpose. Then IGB grade feature extraction, it is nothing but the at a particular enhanced image, whatever previous step we are getting from this enhanced image, XY, any point, we are computing within a window this mean value and your difference of the gray. This is our, we are calling the internal gray variance. So using this internal gray variance image, we are now the input image is the enhanced image. So we are finding the maximum and minimum value from this enhanced image, and GRI corresponding HRI are the gray value and frequency of that particular respective enhanced image. Then compute the mode. Then standard deviation with respect to mode we are getting. Then select the threshold value, that is the homogeneity factor. If standard deviation is greater than T1, then we are going to step 5, otherwise step 7. So select parameters new. This is the Gaussian multiplier. We are collecting all the data which are satisfied this particular range. Then eliminate from this particular range all the gray value because they are most homogeneous. Then the rest of the data are divided into 2 parts like this. Then repeat the same procedure. We are getting the your seed point we are getting from the enhanced image. Now this particular seed point, if we apply in the enhanced image, then more features are comes out. So what we are doing that whatever the seed points we are extracting from the enhanced image, now all those points I am going to for my IGB feature space. From that IGB feature space, we are getting the seed point, which is 1-1 mapping to this enhanced image. Then all these seed points are computed, and then we are applying the multi-seed clustering technique. Here I am giving one example, the multi-seed, which I have published in the IEEE Conjunction of System Man and Cybernetics. This particular vegetation class like this, the vegetation, concrete, and water body. We have seen that when we are collecting the training samples, they are actually elongated. Now, if we apply a single seed-based classifier, then the classification result is not better when we are taking the single seed. Whereas if we apply the multi-seed technique, that means it is a non-Gaussian field. We are combining this non-Gaussian field as a union of the Gaussian field using that concept. That is also in the paper, IEEE paper, in the multi-seed classification technique. Using this multi-seed classifier of the IGB feature space, we are applying the further clustering or man-made structure isolation from the rest of the image. This is the next is that after applying the cluster, then it is also again a gray level image with limited gray variance. It is very easy to convert a binary image for isolation of man-made and natural objects by simple threshold technique provided appropriate selection of threshold value. That is important. So I am applying the biomodality detection approach. here the bimodality detection approach, what is that? That whole image is, suppose the population is Q. Now I have to find out one value U, so that it will divide into two parts, QLU and QHU, in such a way that this particular includes the data of the group value less than equal to U, it is greater than U. Then the variance of QLU and QHU are small in respect to Q. That is obvious. Now suppose n and sigma squared are the total frequency and variance of Q. Similarly, we are finding the NLU and sigma square LU of the variance, frequency and variance for QL cluster, and this is for QH cluster. Then objective function for the detection of the threshold value is this. This is the combination of the objective function. So for all value of U, we are finding that for which OBU is minimum. So that value will be my threshold value. Using that threshold value, I am binarizing the particular IGV clustered image like this. So this is my segmented image. After segmented image, then I am finding the circular fitting by the Hough transform. Then after finding these particular circular features, then some of the features are isolated. So we are actually eliminated those that are not interested for us. So only the clustered of oil tanks, clustered of circular features we are extracting. So for that MST based spatial relationship group operation we are applying. In that case, suppose k number of circular shapes we have extracted from the IGV clustered image, then compute the center of the cluster, each cluster, then construct a MST. If the edge is the equivalent distance, that is obvious to connect the nodes. This edge threshold is TGP. If it is less than, then they are same class, otherwise it is the other class. Now we have applied this particular technique to our Iconus and QuickBird images. For TGP, we are taking here 12. It depends on the resolution of the data. So then after this, we are getting the full your circular shape images. So now already we have stored your million of data for the 15 dimension different type of features of the oil tanks. So using this particular training data, we are classifying the extracted circular shape features, which is matching mostly with the oil tank, and finally we are getting that particular oil tanks. Here there is a result. This is the Iconus panchromatic data. Now this is the original image and this is enhanced image. After applying the enhanced image, binary operation is this. If we apply if we apply a canny edge operator, it is not an edge operator. We are clustering this. And beautiful is that within a particular region, since they are homogeneous, so and the border region is heterogeneous, so we are getting only the border, which looks like a edges. It is not edge. Our clustering method by Multisig techniques we are getting. It is mostly the edges. It comes out if you look that they are all the man-made structures, not the natural phenomena structures we are getting. But whereas if you apply the canny edge operator, all the features which comes out, which is very difficult to isolate the man-made structure. So that's why we are applying here our new methodology. Now the Hough transform, we are getting the circular shape, and final the result is. We have applied in the various Iconus and QuickBird data. Here some of the samples are there. And we have compared with the Yan algorithm also, how they have detected, what our detection. Here, these particular bright oil tanks, they have able to detect here. But in our case, since it is a morphological enhancement technique, so the bright structure will be more brighter and the dark structure will be more darker. So that's why we are also able to find out these particular structures which is not able to find out the paper. Now the conclusion is that here multiple steps are we have described in the paper. automatic detection of the oil tank from the high resolution panchromatic data. The problem may be application for the civil, commercial, and military domain. The significant models are projected. Image enhancement technique for highlight the target from the background. Multiple seed-based clustering technique of the internal gray variance. Then binarization and the thinning operations we are applying. Circular object detection by Hough transform. Image the spatial resolution relationship with the for cluster formation. And supervised classification using statistical and textual features. We have applied in the Iconos and Quickbit data. Presently, we are working with this particular methodology by the machine learning and deep learning process. I don't know how they are able to apply the deep learning because a lot of data is required and the architecture is more complicated. Definitely, we are going for the machine learning process to apply this particular technique. Then it will be good work for us. So this is our futuristic. That's all. Thank you. Any question, please?
Any questions? I had a question here.
Yeah.
So really the Hough transform and others have been used for all kinds of other object recognition. And you're doing really object recognition in some fashion. So to what extent your technique could be generalized with multi-seed-based clustering techniques and binarization and thinning operation to other geometric objects of various types, which might be cylindrical, which is what you are doing actually. You're not, but I'm thinking about oval and other kind of objects.
Yeah, that also we are looking after. They see it is a particular object we are looking after. Now, in general, if you able to your storage the particular training samples of all kinds of man-made objects and the same architecture by the minimum classifier route where we can isolate the various type of objects where now here we are concentrated the oil tank also. Now oil tank and the other building or other type of objects we can isolate.
I see. But now, how about some simple edge detection algorithms of types?
Edge detection, that's why I have told you that edge detector, like your canny edge detector, which is the very optimal,
yeah.
we have applied that. But if you look our result here, I didn't show the canny edge operator how it looks when we apply the original image. See, this portion is a lot of variations is there, particularly. This portion is the natural, it is the trees type of thing.
Yeah.
So, which I am not interested. I am not interested. So I am only interested in the man-made structure. So that's why if you look these particular edges, which is not as a edge operator, by our multi-seed clustering based in the IGP domain, we are getting this result. And this result, if you compare with the canny having a lot of edges of the natural objects also, which is not our interest, like this. This is a total tree. Here, this is a blank.
I see.
Blank. That's why the beautiness is here. That since we are looking for the man-made object, so only the man-made object edges I am interested.
I see. I see. So they're really you're interested in regular objects rather than irregular objects like empty spaces and so on. I see. I understand it now better. Thank you so much.
Okay, thank you.
Any other question for Devasis? Thank you, Devasis. And Devasis, I'll have to sign off right now, but please continue with the rest of the talks, please.
Sure. Okay.
Thank you.